Every living thing has a life cycle. For us humans, we are born, get older with time, and eventually die when our bodies are depleted and can't go on any further. Stars also go through a similar natural cycle throughout their existence. This cycle begins with birth, expands through their entire lifespan, characterized by different phases of change and growth, and, like humans, eventually leads to death. However, the time frame in which the life cycle of a star completes is extremely different from those of humans or any other living being. While we may only last a few decades, the life of a star is billions of years long. In fact, some of the stars we can currently observe in the night sky may already be dead. This is because their light travels millions upon millions of miles to reach the Earth. By the time it reaches us, the life cycle of the star may have already ended. In today's video, let's take a deeper look into the life cycle of a star and the different stages it goes throughout its existence. The life cycle of a star is largely determined by its overall mass. The bigger a star is in size, the faster it burns, and the shorter its life cycle is. The mass of a star is determined by the amount of matter which is available in the nebula it exists in. All stars are formed in a giant cloud of dust and gas drifting in the endless void of space. These clouds of debris are called nebulae. Over time, chunks of this gas and debris are pulled together by gravity and collapse upon themselves. This causes the massive deposits of hydrogen gas contained in the nebula to be pulled together and start spinning. As this gas spins faster, it starts heating up and becomes what is known as a proto-star. This is how stars as we know them first come into existence and start their journey through life, which lasts billions of years. Our Sun, one of the biggest reasons for life on Earth, went through the same process in its infancy. Currently, the Sun is classified as a main sequence star and will continue to shine brightly for millions to billions of years to come. Whatever the size of a star may be, they all follow the same 7-stage cycle of life, which starts as a cloud of gas and ends as remnants of the once mighty celestial body. Every star that exists starts as a giant cloud of gas and debris. This is the first stage of stellar evolution and marks the start of the life cycle of a star. The overall temperature in the cloud must be low enough to support the synthesis of molecules. The process of formation begins when a particularly dense region of this gas cloud begins to warm up and shrink rapidly. This is usually caused by one of several possible events that may take place in the vicinity of the cloud. These include things like galactic collisions or an incredibly powerful supernova explosion, which could send ruptured matter into the cloud at very high speeds. Such an occurrence can initiate a gravitational collapse of the molecular cloud significant enough to trigger the birth of a new star. Each of these gas clouds can contain enough matter to form anywhere from a few dozen to many thousands of stars. To put things into perspective, our Sun is 864,400 miles across. This means that it would require a collection of dust and gas which is about 100 times the size of our solar system to form. The Orion Cloud Complex, located in the Orion system, is one example of a star that is in this stage of its life cycle. When the gas particles contained in the molecular cloud constantly collide with each other, heat energy is produced. As the temperature keeps rising due to this reaction, it results in the formation of a warm clump of molecules called a proto-star. This is the second stage of stellar evolution. The creation of such proto-stars can be easily observed in the universe with the use of infrared vision. This is because these infant stars are much warmer than other materials contained in the molecular cloud. Depending on the size of a molecular cloud, it could support the creation of several such stars at the same time. This warm clump of molecules can be classified as a proto-star for as long as other matter keeps getting pulled inside of it. For stars that are the same mass as our Sun, this phase of stellar evolution can last approximately 100,000 years. After this, the proto-star stops growing in mass and the disk of debris that surrounds it is destroyed by radiation. If the proto-star is unable to acquire sufficient mass, it will instead turn into a brown dwarf. These are classified as substellar objects that can't sustain hydrogen fusion reactions in their core due to a lack of mass. A brown dwarf is an object that is too big to be called a planet, yet too small to classify being a star. These objects were only a theoretical concept until 1995, although today it is thought that there is a brown dwarf for every 6 stars in the universe. When matter eventually stops falling into the proto-star and a tremendous amount of energy is released by the object, it signifies that the star has entered its third phase of stellar evolution and can now be classified as a T-Tauri star. The overall temperature of a star in this stage of its life cycle is not high enough to support nuclear fusion in its core. This phase lasts for around 100 million years, and when it finally ends, the star is ready to enter the most extended phase of its developmental journey. The main sequence is the fourth and the longest phase of stellar evolution. It is the phase our sun currently sits in. It starts when the core temperatures of the star finally get high enough for nuclear fusion to commence. During this process, the protons of hydrogen are converted into atoms of helium due to an exothermic reaction. This means it gives off more heat than required, allowing the core of a star in the main sequence phase to release a tremendous amount of energy for most of its life. As the star continues to convert hydrogen atoms into helium for most of its life, eventually the hydrogen fuel contained on its surface runs out, and the internal reaction which has been taking place in its core for millions of years suddenly slows down and stops. Without this reaction, the star starts to cool down and contract inwards through gravity, which causes it to expand. As this expansion continues, the star first turns into a subgiant star, which eventually leads it to becoming classified as a red giant. This is the fifth stage of stellar evolution. Since red giants have drastically cooler surfaces compared to main sequence stars, they give off a red appearance rather than the yellow we are so accustomed to thanks to our sun. As the star expands, it causes the helium molecules found in its core to fuse. The energy released from this reaction prevents the core of the star from collapsing. Once the fusion of helium molecules ends, the core shrinks and begins fusing carbon. This process keeps repeating until iron appears in the core. The fusion reaction, thanks to the presence of iron, then starts to absorb energy, causing the core of the star to collapse. This implosion is an event that transforms massive stars into a supernova, and smaller stars similar to the size of our sun contract and then turn into white dwarfs. This is the sixth stage of the life cycle of a star. In the final stage of its life cycle, the implosion of a star causes most of the debris from its outer layers to blast away into space. The core of the star, however, implodes and turns into either a neutron star or a singularity known as a black hole. Stars that are not too massive avoid this implosion, but instead their cores contract into tiny hot stars known as white dwarfs. Stars that are smaller than the sun don't have enough mass to burn brighter than a faint red glow in the night sky. While these stars are hard to spot, they are very common in the universe and can last for trillions of years. We owe stars our lives. Without them, the ecosystem of the universe would be incomplete and nothing as we know it would exist. Whether it's big stars or small, young or old, one thing is for certain, stars are some of the most important and beautiful objects in all of creation. We hope you found today's video informative. If you did, please leave us a like, and remember to subscribe to join us on this journey of knowledge and discovery of the cosmos. Do you think life on Earth would survive if the sun went out? Please share your thoughts in the comment section below.